Well, let's assume that you are a student of mathematics and say a BSc, bachelor student, and you're wondering what to do. Well, so what I would like to broadly advise is that the first thing is a matter of attitude. See, you should remember that you know while passing exams, scoring good grades, having a good mark sheet is of course important, but that is not an end in itself. What is an end in itself is true acquiring of knowledge. It is to really love your subject, to see what is beautiful about it. Okay, see, if there is no beauty in what you see or what you learn, then it's not worth doing at all. Okay, so the great Adi, who brought Srinivasa Ramanujam to the fore, he's supposed to have said that the greatest test is one of beauty for anything in mathematics. So in that sense, you see, whatever you read, whatever you hear people talking about in mathematics, whatever you come across in class or in textbooks or in material that you find in YouTube or on the web, anywhere, or in books or in magazines, what you must understand is that you must ask yourself certain basic questions to appreciate it. Why is this relevant? There are many things in real life which are directly connected to mathematics, but you don't see it immediately. Okay, so you must be aware that, for example, there's a lot of coding theory, cryptography, number theory that's going into to form the basis of faith, based on which encryption and decryption technologies work and allow you to go to your mobile phone and make a payment without somebody else stealing away your money. Okay, so there's math there, and then this almost everything in engineering and physics, and now it's spread to medicine, biology, and so on. There's no area of science which doesn't involve mathematics. Mathematics is there to whenever you're looking at a quantity that you want to measure and then study, you need math, right? You need a formula. Then of course the scientists or engineers will bring in machines to take the readings. And again, once you get the readings, to fit it into a nice curve, you need interpolation techniques in mathematics. Weather, for example, is predicted by mathematical models. So, I mean, mathematics is everywhere. You should just see it everywhere. And you may not, you must be, at least to begin with, aware of this. Then later on, as you learn more and more of it, you see how deeply it plays a role. Okay. So it's not, you should not think of mathematics as something that's put down in textbooks, and there's a teacher who comes to class and tells you about definitions and proofs and theorems or works out some problems, and then you do the same thing in the examination and get your marks and walk off with a degree. That's not mathematics. I mean, mathematics is, you should appreciate it truly as a queen of sciences, as an indispensable language and tool to get along with everything, right? So this is the attitude towards mathematics. Don't have this attitude of I took this subject because for whatever reason, and then I have to pass, then I have to get my degree and walk off. That shouldn't be your attitude. Your attitude should be one of true learning, true appreciation. Okay. So, and now comes trying to how do you really do this? So suppose you go to class, or you listen to a lecture, or you read a book. Okay, each one of these have to be done treated in a different way. So, for example, when you go to a class or you're listening to a lecture, okay, you should make it a point to keep a notebook or a pad and a pen, and note down things. Okay, it's very important to note down things, because you might lose certain things that are being said. They may just evaporate the moment the lecture is over. You must note down things, but at the same time you don't have too much time to note down, so you should note down in say telegraphic language or in short language, shorthand if you want, in your own notations, so that you have to think about it later. See, this brooding about what you heard, thinking about what you heard, and thinking really like a child, think openly. It doesn't matter if you are very naive, you make mistakes. It really doesn't matter. Let me tell you that most of the time you think freely, let the thought flow, do the most natural things. And yet, if you come across mistakes, then you will see these are the natural mistakes, and these natural mistakes are the stepping stones for you to understand why certain technical things are there in the first place, as opposed to being exposed to those technical things directly, which then sound very unnatural. Okay. So it's very important that you must note down things in a lecture. You must go back and think about it. You must ask questions like, why is this interesting? And if the lecturer didn't tell you, then you must try to go. Nowadays you have a lot of stuff on the web, you have the internet, you have access to all kinds of e-books and now so many videos. You must go and find out why something is interesting, how it is connected to other things. And well, for a person who is, for a layman, number theory is interesting because if he realizes that cryptography is being used in his day-to-day transactions, then of course he will realize that it's important. Okay. So in this way, you have to find things which make the topic that you're studying interesting. Okay. And if this is not there in the lecture, you will have to do it yourself. Now it's not very difficult because a lot of information is available on the web, right? So you should do this. This is called reading on your own. You must feel free to refer to any resource, whether it is the web or videos or books or magazines, but you have to find out why something is interesting. Okay, that gives you the appetite to learn about it. Once you have the appetite to learn about it, the next thing is that you need to go to really the task of learning it. Now, how do you learn things? Now, this is just slightly more complicated in the sense that of course teaching is a skill, but teaching to learn is a higher skill. So rather it's very important for you from lecture not only to learn the stuff of the lecture, but to learn it to a level that you can yourself talk about it. Okay. So in that sense, you will have to see what is the logical structure on which whatever you are learning is built up. So this leads to foundations, basic definitions or axioms. You always start with some axioms, and then you logically build up results, and then this is how you, just like you have a building. You have a foundation, and then you build brick by brick. So in that sense, this involves a good idea of logic. Okay, and you must be clear about logical arguments. You should understand contradictions. You should understand implications. Okay, and the other thing is that you should look at examples. Okay, if you don't find an example, you can always go back to any source like books or the internet and find out examples. Okay. Examples help you to visualize things. Right? And the third thing is also to think beyond and think freely. I mean, you should think just as you would behave if you're playing a game. Right? So you could say, well, where does this lead to? What can I dream about this? It's a lot about dreaming. You really dream about concepts, and whether you think whether there could be better concepts, there could be better ideas. And you have to be very naive. The more naive you are, the more natural you will think. And it will expose two things. On the one hand, if you had good ideas, they'll come out. If you get some blocks, then they'll point out to where you have to certain things that you've not understood properly. And then you can go and go and clarify those black specks. Okay, so it's very important that you have this attitude of trying to really learn mathematics for the sake of mathematics, not only to pass exams or to be able to face an interview or to get degrees. Okay, so with that attitude, and in fact this is the attitude that you should have towards learning anything, not only mathematics.